by themselves, AI agents are kind of
isolated.
Yeah, right. They can reason by themselves, they can generate stuff by themselves. But how does one agent talk to another agent or talk to your existing infrastructure?
That's where it can get messy. Lots of custom integrations to things like data stores or code bases.
Yeah, and look, the industry knows this is a problem. So naturally, we got protocols. A2A, MCP. Maybe you've seen these acronyms floating around.
And maybe you're wondering how they can be used to help agents and which one you're supposed to use.
Well, look, I'm a bit of an advocate for MCP, so I'll take that one. But first, Anna, convince me why I need A2A in my life.
If you're doing anything with multi-agent orchestration, you should absolutely consider A2A, Martin. A2A is short for agent-to-agent protocol. So essentially, siloed agents can communicate and work together regardless of differing vendors or frameworks.
Okay, so whether you or I or somebody else built the agents, does that mean they can still work together?
Exactly. It's an open protocol that defines how AI agents can exchange messages and task requests between each other. And these messages can be requests, responses, and even negotiation or coordination steps.
All right, fair enough. But how do these agents know how to collaborate with the other agents here? Like, do they have a digital name tag or something?
Actually, yeah, kind of. With A2A, agents use something called an agent card, essentially a standardized descriptor to advertise what they can do.
Okay, an agent card. That's a fancy name for a resume.
Yeah, exactly. Other agents can discover these cards dynamically and figure out what skills or services are offered and decide, hey, you do that, I'll do this, and pass tasks back and forth.
Okay, that's pretty elegant. But my agent here, it still needs to talk to my database. So is A2A going to do that for me?
It's not really what A2A is for.
All right, noted. We'll come back to you, Mr. Database. But another question for you. So if I've got a variety of different agents and they use different modalities, so let's say this agent here, this is primarily a text modality agent. Maybe this one primarily works with images. Can they understand each other, or would it be like us trying to speak two different languages?
So that's actually another plus of using A2A. Once discovered, agents can send structured messages or task requests to each other, and these exchanges in information are modality agnostic, meaning agents can swap images, files, structured data, not just text. And if you have one agent generate a design mockup, another agent can review it, and another can be a client approval agent, all part of the same flow.
All right. And then how do these two agents, you got this arrow here, how do they communicate? What's the transport layer?
It's just plain old HTTP, so any existing web server, API gateway, or infrastructure that speaks HTTP can host an A2A agent just like a normal web service. But the magic is really in the data format and communication style.
And whenever I hear the word magic in text, it's usually followed by a bunch of acronyms.
Indeed it is, and here's one for you. A2A uses JSON RPC 2.0 for request and response payloads. That means agent-to-agent communication happens via structured JSON, which is language agnostic and widely supported.
Nice. So you're getting the benefits of web infrastructure, like, I guess, routing, security layers, load balancing, logging, that sort of stuff. And because A2A is building on standard HTTP and the magic of JSON RPC, it integrates easily with existing backend stacks. I'll admit the transport layer story is pretty clean.
Starting to come around?
I mean, I'm listening.
Well, how about this? A2A isn't just for quick call and response tasks. You'll like this one, Martin. For long-running jobs or workflows where agents need to send progressive updates, A2A supports streaming updates via server-sent events. That means one agent can push status updates and partial results to another in near real time.
Meaning that remote agents can send back intermediary progress while they work. That's live streamed progress updates, which seems useful.
Just useful, Martin.
Very useful. But that still leaves the question of how a single agent gets context, which conveniently is what MCP handles.
Convenient indeed. All right, convince me.
It'll be my pleasure. So A2A handles agent-to-agent communication, but what happens when we've just got a standalone individual agent that needs access to external data or tools? Well, MCP is what happens, at least if you want to provide a way that access is done in a standardized way.
And MCP is Model Context Protocol?
Model Context Protocol, giving a single agent the context it needs to actually do useful work. And that might be work like pulling a file out of a file system. It might be work like interacting with an existing code repository. It might be something like writing to a database.
Well, Martin, couldn't I just write code to do all these things?
Yeah, you sure could. And you'd be writing it again and again because you'd have to write it every time you swap models or every time you swap tools.
Okay, I'm listening.
All right, so look, MCP creates a layer, and that layer is where the AI agent doesn't need to know the specifics about how to interact with any of these resources here. There's a really simple infrastructure around this.
I sense some boxes and lines are incoming.
Yeah, you do. Okay, so we've got first box is an MCP host. This is the AI application where the agent actually runs. And then below that, we've got the actual MCP server. And the MCP server knows how to communicate to these resources like the file system or the code repo or the database. But it does so while presenting a uniform interface to the agent.
A uniform interface how exactly? Like if my agent wants to retrieve a file from the file system or wants to edit a line of code in the repo, what does it do?
Yeah, it uses primitives that are exposed by this guy, the MCP server. So there's a bunch. You've got tools. Now, these functions are things that the model can invoke. So it could be a tool to, for example, search the database or commit something to the code repo. There are also resources, and these are things that the model can read, like files or database records or maybe live application state. And then the third primitive are prompts. So these are basically pre-built templates that help the model interact and that serve more efficiency.
Okay, so the agent doesn't need to know how the database is implemented or which API works best with the local file system. It just kind of passes the requests to the primitives exposed by the MCP server, and it handles translation. That makes a lot of sense.
Why, thank you.
Well, in theory, at least. But in practice, how does the MCP host communicate with the MCP server?
Yeah, okay. So like A2A, the message format is JSON RPC. But the transport, actually, that depends. It depends on where the server lives. So for local servers that are running on the same machine, let's say like maybe an IDE plugin that's accessing your local file system, well, it uses just standard input-output for that. But if we are talking about something that is not on your machine, a remote server, that is a different kettle of fish. Instead, that uses HTTP with its streaming support.
Okay, so you write an MCP server once, let's say for a CRM system, and any MCP compatible host can use it. And what happens when you bring in a new model or a new application?
Yeah, it doesn't matter. You're not rebuilding the integration every time. Just reuse the same MCP server, and because it's open, there are a ton of pre-made MCP servers. There's an MCP server for all sorts of file systems, for Slack, for GitHub, for databases, and so on.
So I think we've both made our case for why A2A and MCP can be useful. So how about we consider a scenario where both A2A and MCP can be used together?
Right. So perhaps let's do an example of a retail store. So we've got our own inventory agent here, and that inventory agent is going to use MCP to interact with some databases. So it's going to use that to store and retrieve information about perhaps products, about stock levels as well.
And if the inventory agent detects products low in stock, it notifies an internal order agent, which then communicates with external supplier agents. So maybe you have one, or maybe you have two, or even more. So that's a pretty nice solution. So you're saying I really do need MCP?
Yeah, you do need MCP, but like you're showing here, you do also need A2A.
So A2A for agents talking to agents, and MCP for agents talking to tools and data.
Yeah, it turns out we weren't competing, we were complementing.
Wow, did you just make interoperability sound heartwarming?
Maybe I did.